Go.
What's up, guys? My name is Travis, and today I will be showing you the toolkit function, absolute value of x. For starters, the graph looks something like this. And it keeps going, but I'm going to stop right here. And automatically you can tell based on the x-axis, which is the domain, and the range is the y. But based on the x-axis, the domain, all of the x values, it's all of the x values actually. So the domain is all real values, which is that R with two lines down the middle. The range would be, since nowhere on the y-axis, goes into the negatives, the range will be y is equal to or greater than 0. And since my equation starts right here, my function rather starts right here, my x-intercept and my y-intercept both would be 0. And since it doesn't go into the negatives on either my x or my y-axis, it'll be increasing. And of course the concavity will be up because it doesn't go down. Now we move on to the chart. Let me switch markers. The absolute value when x is -6 is 6. When x is -5, it's 5. When x is -4, it's 4. When x is -3, y is 3 on my chart. But I didn't keep going, but if I kept going on the chart, you can tell that all of these, this corresponds to this, and vice versa. When -2, when x is -2, y is 2. When x is -1, y is 1. When x is 0, y is 0, of course. 0, 0. And when x is 1, y is 1. Now we move along to transformations. Now, we switch markers back again. If you want to do a vertical transformation, then you put the negative in front of the whole equation. This is for vertical. Just write vert. For horizontal, you put it in front of the x, like so. So the vertical transformation, type it into my calculator, would be negative absolute value of x, which looks something like that, or this. My horizontal flip, put that in my calculator. Will look like this, which looks exactly like the original equation, depending on where you're starting from. Now we move on to the harder ones, which adds numbers to the absolute values. I added negative absolute value of x plus 3 and absolute value of negative x minus 4. And I'm going to plug that into the calculator. Plug this one into the calculator, you're going to get 3 graph. The equation that looks like this. So it's on 3. And since my negative is on the outside of the absolute value, you can tell that this is a vertical flip. Now for a horizontal flip, I already know because the negative is in front of the x, which I told you earlier that means it makes it a horizontal flip. We're going to plug that into the calculator. And when we do that, we get 4 graph, an equation that looks like this. And there you have the toolkit function and all the transformations to this function and the characteristics of this function, domain, the chart that corresponds with the function itself on the graph. The toolkit function, absolute value of x. My name is Travis Postman. Have a nice day.